Okay, so I think this will be the last video, but it's an important topic, so I'm not disappointed in spending 4 sessions on this. So here's an expression that kind of looks like an irrational function, but is not exactly a rational function in this particular form. Now, one thing you could do is you could plot this and then just add 1 to it, do a vertical shift to 1. Probably the best thing to do is to combine these two into a single fraction, into a single rational expression. So what's going to happen is 1 is just something divided by the same thing. And of course, in this case, that something is the denominator of the second part. So we're going to use that. So now we have common denominator, and so we have x minus 3 minus 3. So that's going to be x minus 6 over x minus 3. So there we go. And now everything that we do is going to be, this it says find any rational zeros. So that's all it's asking, but we'll go ahead and plot the thing too. So what are the things we do? One is we look for the y-intercept, and that's where you set x equal to 0. So if you set x equal to 0 here, you're going to have negative 6 divided by negative 3, which is positive 2. The second thing is we find the x-intercepts, or intercept, in this case, intercept. That's where the numerator of the rational function is set equal to 0. So you get x equals 6. So that's my x-intercept. 3 are the vertical asymptotes. That's where you set the denominator equal to 0. In this case, the denominator is x minus 3, so you get x equals 3 as the vertical asymptote. And the horizontal asymptote use the rules, and in this case we have the same order in the numerator and the denominator to the first power, so and our leading coefficients are implied to be 1. So you just end up with y equals 1 because you get these leading coefficients. Okay, so given that information, we can get a piece of graph paper. And so we'll plot everything that we have so far. Y-intercept is 2. X-intercept is 6. This is assuming we're going to use the scale. I'm just going to, since this is a bonus here, I'm not going to put all the numbers in. Okay, then we have a vertical asymptote x equals 3 and horizontal asymptote of 1. So I'm going to draw that out here. Oops. Just going to draw that out here. Now, I could pick some extra points, but so if I did, I might pick a point here at x equals 1 or x equals 2, because I know this is going to go up like that. And I could pick a point here at x equals 4. That would give me a point down there. But because I've got this horizontal asymptote, I know it's not going to go below there. Well, I don't know that for sure, but it does. So if you picked another point over here, you'd find out it's above the line x equals 1. So we come along this asymptote, we go through this point, and you see we're going up. if we went the other way, then we'd have another x-intercept, which we don't, because if we came down, we couldn't cross this line because it's a vertical asymptote. So there's only really one choice here, and that's going up like that. And because we have a single root in the denominator, we know that when you go to this vertical asymptote, you're going to bop over to this side. And also because this x-intercept is on this side of the horizontal asymptote. So that's what it looks like. Okay. Yeah, we've already looked at that. I guess we didn't, you know, the only things we have are that the y-intercept is equal to y equals -1/3. That's because you set this equal to 0. B, the x-intercept is there's none because the denominator never equals 0. The vertical asymptotes are x equals 3. That's what makes the denominator go to 0. And the horizontal asymptote is y equals 0. And that's because if you think about the order of the numerator, which is x to the 0 power, which is 1, 1 is less, 0 is less than 1. So when that happens, you get that. So using that, you can plot it. So let's just do these here. Here are all the guidelines. So let's put them on one page here. So A, y-intercept. That set x equal to 0. So you get 0 squared over -9. So you get y is equal to 0 squared over 0 squared minus 9, which is 0. Okay, so that's the y-intercept. B is the x-intercept, and you solve that by setting y equal to 0, which to get y equal to 0 in a rational function, you set the numerator equal to 0, and so this is 0 squared is the only solution. Then we have the vertical asymptotes, so that is the denominator, which is x squared minus 9. That has to equal 0, and you can factor x squared minus 9 to x plus 3 and x minus 3. And so there are two vertical asymptotes, one at x equals 3 and one at x equals -3. And D, which is your horizontal asymptote, is y equals 1. And that's because the order of the numerator is the same as the order of the denominator, which is 2. So you take the ratio of the leading coefficients, 1 over 1, which is 1. Okay, so those are the things that we need to know, and we can plot some additional points, but let's just write down what we know so far, or show what we know so far. So y-intercept 0, x-intercept 0. So here we go. That wasn't it. Let me get rid of that little dot that I used. Okay, so that's my x and y-intercept. Okay, the next is the vertical asymptote. So we have two vertical asymptotes. One at x equals -3, 1x equals +3, and we have a horizontal asymptote at 1. Okay, now so we could evaluate the function f of -2 f of positive 2, which would give us points right here. And then we could do, let's say, f of 5 and f of negative 5. And again, because of symmetry, we probably only have to do this once, but so the function is x squared over x squared minus 9. So here you have negative 2 squared divided by negative 2 squared minus 9. So that's 4, and negative 2 squared is 4, minus 9 is negative 5. So you get negative 5/4, and you can see you get the same thing here at positive 2, because negative 2 squared is the same as positive 2 squared. So you get negative 4/5. So these are down here. And if we let these be 1 unit, 4/5 is going to be about 1. And 4/5 right there. So, we know that this thing has to go like this, because if it went back up, you'd have to have another x-intercept, which we don't. So, and this doesn't really cross the x-axis. And that's one property here of x squared. It gives you just where it just touches the x-axis. It doesn't actually go through the x-axis. Now, what's going to happen is this is going to be up in this quadrant, and this is going to be up in this quadrant. And partially is because of symmetry, and partially because if I have x large positive, this number becomes insignificant. So you're going to have positive numbers, which means it's going to be on the positive side of this. Well, it's going to be a positive number for one thing. And if we had on the negative side, we'd have to cross the x-axis, which we don't have any. We don't have any intercepts, so it has to be in this quadrant. So this calculation is just going to tell us how far up here it is. So we have 5 squared over 5 squared minus 9, which is 25 over 25 minus 9 is 16. And that's just some fraction. 25 divided by 16, 1.56. So that puts that right. We said f of 5. 1, 2, 3, 4, 5. What did I say it was? 1.56. So 1.5 is right here. And this one's going to be the same place. So this is going to go down like that. And then this is going to go up like that. And we also know this goes from positive infinity to negative infinity because we have single roots in the denominator. Okay, so here now we get a little bit exciting. How many of these do we have? Not too many. Almost done. Okay, yeah, let's see what we're doing here. So this is kind of this is the most difficult one, which is more difficult than we would normally have. So what we want to do first is see if we can factor the numerator and the denominator, and I'm going to assume that this is going to be something that we can factor, at least the numerator. So, to get 2, I'm going to have 2 times 1. And this is negative 3, this is negative 5, so they're probably both going to have to be negative to get a negative 5, which is more negative than negative 3. That's not true. So this will be plus, and this will be minus. Okay, so you see that works out. 2x times x is 2x squared. Then you have negative 6x plus 1, which is negative 5x, and positive 1 times negative 3 gives you negative 3. So we couldn't have both negative. Okay, so now what we need to do is figure out how to factor the denominator. And there aren't that many rational roots that are available. Plus and minus 1 and plus and minus 2 are the only ones. So let's just try just wait a second. There we go. Okay. So we're going to use synthetic division and try what's going on here. Hold on just a second. My cursor's not responding. Okay, there we go. Okay, so we're going to so we write the coefficients 1, -2, -1, 2. And remember, the number we put here is not the factor, but the x value. So this is assuming x equals 1. So that's 1. Bring this 1 down. 1 times 1 is 1. -1 plus +1. -2 plus +1 is -1. -1 times -1 is -1. Add those together, you get -2. 1 times -2 is -2, and we get 0. So we know that one of the factors is x minus 1. That gives us a 0 of x equals 1. And then we're left with this polynomial, or this quadratic. So we have x squared minus x minus 2, and that also has to equal 0. So you're going to have x, and one's going to be positive, and one is going to be negative, because we have a negative here. And because that's a negative, we put the bigger thing with the negative side, and the smaller part with the positive side. So we get x, so we get 3 factors. And this is, so we have x minus 1, we have x plus 1, and we have x minus 2. Okay, so what that means is that we have enough information to find everything except extra points, which we're probably not going to do. You can do that if you'd like to get a more accurate result, but let's start off with a or 1. My cursor's being funny again. Okay. Okay. Give the computer a little break here and it goes crazy. Okay, so we'll say A1, 1 y-intercept. We always only have 1 and y-intercept if they're functions. Anyway, we set x equal to 0. We use this form, the unfactored form. The only thing we have left is the last 2 terms, which is -3 over 2. So it's -3 halves. Okay. Here we set the numerator equal to 0, and we factored the numerator as x plus 1 and x minus 3. So our 2 x-intercepts are going to be x equals -1/2. So if you set that equal to 0 and solve for x, you get x equals -1/2, and you get x equals +3. Okay, then you have your vertical asymptotes. That's where you set the denominator equal to 0. And again, because we have it factored already, we're going to have 3 vertical asymptotes. 1 at x equals 1 associated with this, 1 at x equals -1 associated with that, and x equals 2 associated with that. So we have 3 vertical asymptotes. And then our horizontal asymptote is just going to be equal to y equals 0, because the order of our numerator is 2 and the order of our denominator is 3, and because 2 is less than 3, this ultimately goes, the horizontal asymptote is that. So now we're going to insert a page. Slowly. Okay, we're going to get some graph paper. And I think I'm going to use a different scale here just to give us a little more room. So we're going to use a little bit expanded scale. So instead of going from -10 to +10, we're going to go from -5 to +5. Okay, so let's plot the y-intercept, which is -3/2. So this is 1, this 1/2. We have x-intercepts at -1/2 and +3. 1, 2, 3. So each grid mark is a half a unit. And then we have 3 vertical asymptotes. So we have one at x equals -1, x equals +1, and one at x equals 2. Like that. And so the question is, what happens now? Do we need to pick some other points? And probably, I think we have enough idea of what's going on here. You know, we know that it has to come from up here down through this intercept, through here, then down to there. Now, because this is a single 0 here, we know that this has to come from this direction. And there's no x-intercept, so it has to stay above the x-axis. So it's going to loop down. We don't know exactly where it's looping to. That's why we're going to evaluate the function at -1.5. Now, since this one approaches positive infinity, this one has to come from -infinity. So we come up like this. We go through the x-intercept, but we don't go up too far because we're going to have a horizontal asymptote of 0, so the thing kind of loops over like that. So there's going to be a little maximum here, and then it's going to approach the x-axis. Likewise here, this is at positive infinity, so we would come from -infinity, and we have a horizontal asymptote of 0 and no x-intercepts here, so it's going to approach it kind of like this. So if we wanted to, you know, get a better idea, we might pick a point here, x equals this or x equals that. The only one I'm really going to do here, just to know how far this thing loops down, is evaluate the function of 1.5, which is right between these 2 vertical asymptotes. So we have, and I'm going to use the non-factored form because I think that'll be easier to evaluate. And what I'm going to do, I'm going to do both the numerator and the denominator separately and just see what they are. So we've got 2 times 1.5 squared or cubed, squared, yeah, minus 5 times 1.5 minus 3. So I think you get a negative answer there. So I get negative 6. And hopefully I get a negative number in the denominator too. And that'll give me a positive result. So I get negative 0.625. So negative 6 divided by negative 0.625 is 9.6. So one little problem is that the scale that I used in this direction makes it so that you don't actually see this thing come down like that. So I probably would change the scale a little bit.